Object-oriented programming, or OOP, is a way to write computer programs. Think of it like building with Legos. In OOP, we create objects which are like Lego blocks. Each block has its own shape and can connect to other blocks in specific ways. These objects contain data, called attributes, and actions they can perform, called methods. OOP helps us organize code better, making it reusable and easier to maintain. It's like having a well-organized Lego box, where you can easily find the blocks you need. OOP has 4 main principles: abstraction, encapsulation, inheritance, and polymorphism. These principles work together to make our code more efficient and flexible. Polymorphism, in particular, allows objects to take on many forms, which is what we'll explore in this essay. Polymorphism is a big word that means many forms. In OOP, it means that objects can behave differently depending on the situation. It's like having a Lego block that can transform into different shapes depending on how you connect it to other blocks. For example, imagine you have a program with different animal objects: a cat, a dog, and a bird. They all have a method called speak. Polymorphism allows each animal to speak in its unique way. The cat meows, the dog barks, and the bird chirps. Method overloading is a way to implement polymorphism. It allows us to have multiple methods in the same class with the same name but different parameters. Think of it like having different Lego instructions for building the same object with different colors or sizes. Python doesn't directly support method overloading. However, we can achieve similar functionality using default arguments. We can define a method with optional parameters, and Python will handle different argument combinations. For example, let's look at a simple class called calculator. In this class, we have a method called add, which takes 2 parameters, but the second one is optional. If we call add with 2 arguments, it adds them. If we call it with just 1 argument, it adds 0 to it. Here's a quick example. Python class calculator calc equals calculator, print calc add 2 3, and output 5 print calc add 2, and output 2. So, as you can see, Python allows us to achieve method overloading using default arguments. Pretty neat, right? Method overloading in C++. So, C++ directly supports method overloading. We can define multiple methods with the same name, but, different parameter lists in the same class. Class calculator, public, int add int a, int b, return a plus b, double add double a, double b, return a plus b, tree, int main, calculator calc, count, calc.add 2 3, endil, idam output 5 count, calc.add 2.5 3.7, endel output 6.2. Method overloading in Java. Java also supports method overloading. We can define multiple methods with the same name, but again, different parameter lists within the same class. Class calculator, public int add int a, int b, return a plus b, public double add double a, double b, return a plus b, from T public class. Main.public static void, main string args. A calculator calc is new calculator. System, the out.println, calc.add to 2 3. Output, 5 system.out.println, calc.add 2 5 3.7. Output, 6.2. Section 4. Method overriding. Another flavor of polymorphism. Method overriding is another way to implement polymorphism. It allows a subclass to provide a specific implementation of a method that is already defined in its superclass. It's like customizing a Lego model by replacing a specific block with a different one. Method overriding in Python allows a subclass to provide a specific implementation of a method that is already defined in its superclass. For example, Let's consider a class named animal with a method called speak. When this method is called, it prints animal sound. Now, if we create a subclass called dog that inherits from animal and define its own speak method, this new method will override the one in the superclass. So when we call speak on an instance of dog, it will print woof instead. Here's a quick example. We have the animal class with a speak method, like this Python class animal, and then we have the dog class that overrides this method, Python class dog animal. When we create instances of these classes and call their speak methods, we get different outputs. For instance, Python animal is animal, dog a dog, animal speak, and output, animal sound dog, speak, and output, woof. So as you can see, method overriding allows us to customize or completely replace the behavior of a superclass method in the subclass. This is a powerful feature of object-oriented programming that helps in creating more flexible and reusable code. Method overriding in C++. C++ uses the keyword in the superclass method signature to enable method overriding. Class animal was public virtual void speak. One coot, manti animal sound. Endel, Gedina. Class dog, public animal, one public void speak. Override, one count. Woof, Endel. Yan, int main. Animal dog, its mana, new dog, e. Animal speak, yekhen. Output, animal sound dog, speak. Output, woof. Method overriding in Java. Java implicitly allows method overriding. If a subclass defines a method with the same name, return type, and parameters as a superclass method, it overrides the superclass method. Class animal wa public void speak wa system.out.println animal sound. Class dog extends animal at override public void speak on system.out.println woof. Public class main public static void main string args animal animal il new animal animal dog il new dog animal dot speak output animal sound dog dot speak output woof. Section 5. Benefits of polymorphism. Polymorphism makes our code more flexible and reusable. It allows us to write code that can work with different objects without knowing their specific types. It's like having a single Lego instruction manual that can be used to build different models with slight variations. Polymorphism also makes it easier to add new features to our programs without modifying existing code. We can simply create new subclasses that inherit from existing classes and override methods as needed. This reduces code duplication and makes our programs easier to maintain. Section 6. Conclusion. Polymorphism is a powerful concept in OOP that allows objects to take on many forms. It enables us to write more flexible, reusable, and maintainable code. Method overloading and method overriding are two common ways to implement polymorphism in programming languages like Python, C++, and Java. By understanding and utilizing polymorphism, we can write more efficient and elegant code that can adapt to changing requirements. It's like having a Lego set that can be used to build an endless variety of creations. So, embrace the power of polymorphism and unleash your creativity in the world of programming.